Today's session, we are going to talk about another agentic AI use cases to see how agentic system can be used to advance cybersecurity operations. I'm not an expert on cybersecurity operations, but I'm very curious to see how agentic AI can automate the operation workflows. This presentation is based on a technical blog from NVIDIA. I also attended their session at the Grace Hopper conference, and I find their presentation very interesting. So yeah, credits to NVIDIA Science for this presentation. First, the rise of the LLM and AI agents. As you can tell, there are rapid advances in LLMs, right? To enable the AI agent to reason, right? To kind of analyze what's the situation, to plan a list of actions, and actually can act by calling the tools, etc., to complete a complicated task. And the AI agent can do all of this automatically. So brief touch points on what is an AI agent. So it's AI agent should be a goal-driven, right? So usually it plays a very specific role there. It's able to invoke the tools directly and able to do iterative reasonings and do the continuous improvement over time. And also the power of AI agent is also it's able to orchestrate dynamic workflows rather than static workflows and can be integrated with various enterprise data systems. Last, I think, is mainly talk about the memories of AI agents. So you can ground the AI agents into any context. And more specifically in today's talk, the context is cybersecurity, right? But I think it can be very general, right? So you need to ground your AI agent with the domain knowledge, like providing the most relevant knowledge in the context or in the memory or the knowledge base of the AI agents. Yeah. So the potentials of using AI agents to automate the cybersecurity workflows is they can be used to automate the repetitive task. Like any operation workflows, I do see a trend of AI agents being used to operate to fully automate the repetitive, easier workflows. And then we can free the human experts for more critical tasks, right? Or for the more high risk task. And also in the cybersecurity scenario, it will also help to accelerate the incident detection and response time. So examples of the cyber agents at NVIDIA, there are mainly two use cases that the team talk about. So one is the alert tri-edge agent. So this is to basically any cloud platform or services, they are going to receive lots of alerts. And then they want to identify the most critical alert from a sea of alerts and able to automatically analyze the alerts and propose what are the actions to take. So this is so this is more like an agent to help the human analyst, right, to automatically provide the recommendations of how to handle the critical alerts. The second use case is the vulnerability analyst agent. So this is more like, say, if you release codes or release services or applications, you need a software vulnerability test, right, to proactively prevent there's any like cyber attack or anything from happening in future. So this is more like a proactive scan of the container that has the application services or anything to detect whether there's any possibility of kind of unsafe access or cyber attacks in future. Yeah. So both use cases require gathering of context for the problem, able to automatically analyze the data, and then in the end, the final outcome of the agents is to provide a structured reports for human review. So basically, in the end, it's kind of facilitate the human reviewer and going to save a state report like up to 30 minutes per analysis for humans. And these agents are developed using NVIDIA NeMo agent toolkit. It is also an open source framework agnostic library for any multi-agent framework, but also provides lots of toolkits for agent development, like the agent development, profiling of the performance, able to evaluate the multi-agent system, and also how we can optimize the performance and latency of the system. So, but this talk won't focus on this toolkit. I'm also thinking about like next year, I'm going to be more focused on the actual deliveries with the frameworks and with the toolkits. Yeah, so let's first look at the first use cases on the alert triage agent. Alert management is critical for cybersecurity. So why it matters? So you can think about like a school of fish, and then each fish represents an alert, right? Some alert can be banal. It doesn't hurt the system or hurt the user experience. And some alert is kind of critical failure, right? And you have heard about the AWS and Azure, all the recent breakdowns of the system, right? So those are kind of the real critical alert, like the services is down and it's going to have a big impact on the customers. So catching the critical alerts is very important, and detection is only half the battle, and the signals of the real attacks or alerts are often buried in a sea of benign anomalies. So usually if the system gets too many alerts, and if you don't have a very good alert management, it means no coverage. So for cybersecurity, so basically it's like too many alerts, you don't know like which one to specifically to pay attention to or take care of. And it may involve lots of time from human efforts to figure out what is exactly happening. So challenges in the alert management. First, as I mentioned, right, so the alerts are in big volume. So there are lots of alerts in the system, especially if you want to run a cloud services that serve many customers. And then the handling alert also requires the domain expertise and also the experience from the site engineer or the SDEs, right? So it has the experience dependency. And also it requires the labor-intensive data analysis in order to retrieve the most relevant signals and information to diagnose the alert. And in the end, you usually need to document it to build the system, the documentation system. How can we manage the alert efficiently? But the documentation also takes time, and usually any human may not be willing to write a very comprehensive document every time, right? So it's time consuming, but I think that's the power of Gen AI, which is to some extent good at writing a long documentation or detailized documentations for the system. And then, so these are the challenges. And then the agentic solution, this is the kind of how agentic system can help to resolve these challenges, right? So the first is the scale, like lots of alerts tickets, right? And then, yeah, we can scale through automation without scaling the team. The second is on the domain expertise. Then for agentic, it's more like you need to build the expert knowledge kind of or store it in a vector database, right? And then able so that for the agentic system to pull, to refer, and to leverage in every, and then we can scale this across different alert analysis. In terms of the labor-intensive data retrieval, well, I think like we can provide like the data querying tools, right, for the agent to interact with the existing systems and monitoring services, and able to retrieve all the context automatically. And then the last part is the documentation. Well, the agent's output is documentation. This is the kind of the outcome of the agent. Kind of the agent is going to provide detailed analysis, some recommendations and conclusions for the humans to further dive deep into the situation or escalate it if the recommendation is not helpful. Yeah, so this is like how the agentic systems can help. And then the end goal is, of course, to reduce the human time spent to diagnose all the alerts. This is the kind of the architecture of the agentic system for the alert triage. So basically, it's kind of like a cloud. You can think about as a NVIDIA cloud services, right? So you have lots of hosts running, and then there's a cloud monitoring system to say, oh, which instance is up or down, or which service is up or down. And then there will be some performance related monitoring to see, for example, whether the GPU is properly leveraged, the resource is properly planned and leveraged. There can be a security alert or system health alert. So that you can define all types of alerts or in your system. And then there will be a triage agent. So this is the LLM, right? So this is the LLM agent that is going to take in all the alerts and also is able to collaborate with another cloud metric agent to figure out, okay, what is the most critical alert or signal right now in the system, and going to write a report, right? So it's going to summarize the situation and going to provide this report to a human analyst in the end. So the inputs is the server monitoring alerts, and then the agent is going to interpret, kind of reason about the alert and propose what are the investigation steps to look through. And then it's also able to connect all the data. So if it has seen the alert and it say, oh, I need to look at other system metrics, right? And then it's able to pull those metrics from the monitoring service and able to analyze the data automatically. And it's also going to categorize, infer what is the root cause of these alerts. And last is going to write a report for the human analyst. And then this is the iterative process, usually like in any multi-agent system. So the key features is, first is event-driven. So there's no human interactions during the investigation phase. But in the end, the results is still presented to your human analyst, right? But like from the beginning, like connection to the monitoring system to up to the report is fully automated without a human interaction. And it's a multi-agent collaboration framework. So I think right now shown over here is like this 2 agent to ensure that each LLM can have a more scoped focus to ensure the best performance. If you're wondering like what is the alert looks like, so this is kind of the alert format, a brief version of the alert format, right? So this is the alerts, and then what is the alert name, in terms of the availability, what's the component, which instance it is, what is the job location region, and what is the service, etc., etc. So this kind of the monitoring systems may generate lots of alerts in certain formats, right? And then these are going to be the inputs to the multi-agent service. This is like the architecture diagram in a greater detail. Basically just extending the previous diagram. You can see of it this way, right? So there is alerts, and then there's a maintenance check. So this means like it's just a command line execution, right? So you may also want to optimize the architecture to replace the LLM with a programmatic process so that you can save the LLM cost and latency. So you will see like the terminal execution or code execution or something like this. So it's kind of like a tool call or program or coding invocation there, right? So this is kind of just a maintenance check, and then it's going to this alert agents. And the input of the alert agents is going to pull all the relevant contexts, right? Including the telemetry. So I think this is as per like what is a telemetry metric is more like a CPU or GPU usage, request rates or errors, latency, etc., etc. So this is more like to analyze the system metrics. And then it's also able to access the network connectivity test to see whether there's any test fails, monitoring services, the host performance analysis, and also the hardware checks. So this basically provides all the relevant signals to the agent so that the agent can reason, okay, this is the situation of the alert. Then out of all these signals provided, which I think is the most relevant and which could be the root cause of this alert, right? And then it's going to also do a categorization. It's kind of like a classification of the root cause to help generate the report to show to the analyst. Yeah, so this is kind of what the report looks like, right? So there's an alert summary to say, oh, this instance is down, and which is the host are reported down. And then it's going to say, oh, this is the metrics that I have looked at, right? So all of this collectivity, this is a monitoring agent from NVIDIA. So the monitoring service on the host is down. So the root cause is the software. And then the analysis tells, well, this is a brief version to say, oh, the hardware and network are okay, but I also noticed the monitoring services is down. And then this is a valid alert, but it's not a hardware outage. And then the report will also contain the recommended action, right? For example, to restart the monitoring service, they call telegraph. Restart this monitoring service to attempt to bring it back, and also check the logs of errors, and also escalate this issue if the problem persists. So this is a report in the end presented to a human analyst, and the human may look at the reports, right? And then it's going to try out the actions or escalate it, say, to a more experienced analyst to help identify the root cause of this. So you can tell the impact of this is going to save lots of human time. So to figure out what is going wrong. So that is multi-agent architecture and also the final report format. Another critical step in building any multi-agent system is you need to evaluate it, right, on some data set. So to measure, because you cannot just say, oh, it seems to work on this one case and it should be fine in deployment. It's not going to happen. So usually, like, you need to create a data set to evaluate whether this performance is good and whether it meets the requirement, or whether it is truly helpful for the human analysts. So they also do some quantitative evaluation. For example, there's a categorization of the root cause of the alerts, right? Like what is the root cause of the alerts? It could be hardware, software, etc. And then they just check what is the classification accuracy, because in the end, the category, there will be a predicted category from the agent, and then there's the ground truth, right? So from the human analyst, and then this is kind of the confusion matrix. And if all the numbers are on the diagonal, it means that it's very consistent with the human analysts. But if there's any number off the diagonal, it means that there's a mismatch between the agent recommendation to the human analyst. So in terms of the high-level categorization of the root cause, the multi-class classification is like 84.6% on 45 samples for covering all the root cause categories. And then you can see that the most confusing part for the agent is distinguishing from the software to need investigation, although I'm not sure what is a need investigation mean. But it's like there seems some like inconsistency with the human analyst categorizing it as a software issue, or just categorize it as a need investigation categories. So this is more like a high-level root cause analysis. And then they also do a human as a judge evaluations to see whether it is truly helpful for the human agent, right? Because in the end, it's the human analysts who are consuming the report. So they are going to show the report to multiple analysts and then ask the analysts to rate it from 0 to 5. So 0 means like not accurate, not relevant at all. And 5 is exactly like the full solution. So basically it captures all the signals, the recommendation steps are all correct. So 5 is like, yeah, it's basically just what the analyst is trying to do. And 4, it means like a very good. So it's almost accurate, but maybe still miss some data points. And relevance is like basically the response, like how relevant it is for that alerts. And coverage is to see whether it covers all the key aspects. And also the actionability is whether the recommendation actions are appropriate or are correct. right? So from the human analyst, so you see the average score, and of course the score will vary from human to human because human don't have one evaluation kind of standards, right? So it's going to vary from human to human, but on average, the analysts still find it like a very helpful to save them time for the final report. Okay, so that's the first use case of the alert analysis. So I will just call it alert analysis. The second use case is the vulnerability analysis agent. So this is more like, say, if you are going to release a service or applications in a container, this is more to detect whether any external attackers can access the data or access the application in an unwanted way, right? To detect the potential risk of the applications. So this is to analyze the software vulnerabilities for a container scan. Okay, let's look at the second use case. And first is more like a little bit background about the vulnerability analysis for the software deliveries. And every release of the applications or services must be secured before it ships out, right? You can think of this vulnerabilities like they are good X and bad X, but they may all look the same from the appearance. So you want to detect what are the potential bad acts there, and whether this could be exploited from external attackers, right, to do some malicious behaviors. So enterprise software releases depend on complex software stacks, right? And each dependency, each release may hide some vulnerabilities that external attackers can exploit. So the security scanners are important to proactively prevent such vulnerabilities or risks from happening. And each vulnerability must be remediated, right? And if remediation is not possible, then so it should be also analyzed for exploitability within the container. Yeah, so that's kind of the context of what is the vulnerability analysis is for the software. And challenges of the manual vulnerability analysis is, so it's just like the alert analysis. It requires connect lots of information, right? Check the resources, explore the database, understand what vulnerability means for your applications. And then you need to determine the exploitability. Exploitability is just like a likelihood. So I think this is just a term commonly used in the vulnerability analysis. So it describes the likelihood that this vulnerability can be used by attackers for malicious purpose, right? So they call it exploitability there. So basically you need to review, this is another term they use, is SBOM. So this is basically just a list of components, codes, modules, and libraries or dependencies in a piece of software, right? So basically you have a list of all the coding packages or modules in your application container, and then to determine whether if there's any risk present. So you need to examine the source code, repository, and documentations, and also analyze the container-specific informations. And then last, you also need to write a report in the end to document what investigation have you taken, and then compile the findings into a standardized report for the future reference. So basically, this is more like a steps of how a human do this vulnerability analysis for a software package. And then the strength of AI agents, of course, is kind of how we can scale this analysis pipeline and how we can distill the expert knowledge into the context, and then able to connect to the system, different data sources, and directly connect it to the code repositories to gather the most relevant information, and in the end, generate the document as a side product. So this is kind of the architecture, agentic architecture for the vulnerability analysis. So at the bottom, you will always see multiple data sources, right? So any multi-agent system sits on your data systems. So, or tools, right? Or infrastructures, let's put it that way. So infrastructure will include all the data, codes, databases, and also the tools that you can use for the multi-agent, right? So there will be some code repositories, the SBOM, right? So the list of modules, and container information, documentations, and also this is kind of the historical CU, I believe, is a CUDA vector search indexing, kind of like a vector databases from NVIDIA. So whenever like an event, so the event here is a potential vulnerability test, right? Because we want to do the vulnerability test proactively. Maybe the attack has not happened yet, but based on the past history, there is a common list of vulnerability component and tests for the human to run the analysis, right? So this event here could be just a predetermined vulnerability component and test to check. And then you need to do some pre-processing of the data sources. And then the LLM is going to generate a checklist so according to the vulnerability component or tests, what are the checklists to perform on your code or application repositories? And then there is a multi-agent framework because you can execute the task in parallel. And then each agent may also have the access to the search tool. So the search can be a vector search, or it also can be a lexical. So this is more like a search, directly search the exact words in your system. So each agent is able to access all the contexts and able to perform the search there, and then can execute the checklist in parallel. And then in the end, it's going to summarize what is the findings there, and then do a critic. So this is a justification to say whether such risk is present or not, and then provide the final recommendations to the analysts. Right? Again, all of this, so the human just need to configure what are the container to check. That includes the code packages, modules, dependencies, etc. And then what is the list of vulnerability components to check, right? So this is more like the events at the input, and then the system is going to run all automatically, and then in the end, it's going to show the recommendations to the analyst to tell if there's any risk in the current container or code packages. Actually, they have NVIDIA Cloud has this showcase of the vulnerability analysis for container security. And also interesting that they are using the Llama 3 70 billion instruct model for the LM agent. And then they are using this as, I think this is the embedding models for the vector search. And then the input is, so you need to specify the container, I think this is container to analyze. And then you also need to specify what is the list of common vulnerabilities to check, right? And then the output is going to generate a summary, a justification to say, like, for example, over here, I think the agent is doesn't think there's a risk. So so it's not executed during runtimes. Does not process potentially untrusted input data that could be crafted to exploit this vulnerability. So the final output will be like this report, right? To tell the summaries, what is the steps, what has it checked, what are the potential functions that may pose some risk, and also to provide the justification, and also it's going to provide a detailed checklist for the humans to inspect whether there's any major things missed from there. So the NVIDIA science team also report the internal deployment and see a very scalable, helpful, and impactful results for this agent. First, every day, the system is able to process 1,600 plus containers and to check against almost 7,000 vulnerabilities. And also productivity boost is able to save the analyst time from 10 to up to 30 minutes per analysis. So which can add up to hours of time saved per week, which means the same team is able to handle more analysis, right, with this agent assistance. And also, it also delivers high impact. Since launch. The agent has helped analyze like 15K critical and high severity vulnerabilities for humans. I think their blog and presentation also show another interesting point is beyond deployment, right? So usually it's not just deploy and that's it. You also need to maintain the accuracy and efficiency post-launch. So they also comment on how they can continuously monitoring the performance and efficiency of this multi-agent system. First, they mentioned about the ongoing feedback loop from analysts. So this is more like an annotation tool, right? So in the end, the vulnerability analysis, they're going to provide a summary, justification, etc. They are going to provide a way for the human analyst to say whether this is correct or not, right? So yes or no. And also able to kind of add a comment here to say, oh, whether there's any major findings missed, or what information will be also good to point out in this section. So they provide a way for the human analyst to continuously provide feedbacks to this multi-agent system. I think this, to some extent, can also help mitigate the prompt ejection issue, because this is the continuous monitoring and improvement cycle, right? So if there's a prompt ejection or something like that, the humans should be more able to be reflected in the human feedbacks, right? And then if the multi-agent system see the prompt ejection is a big issue, then they need to close that loophole based on the human feedbacks. So we cannot bypass this, right? So we, for any agentic use cases, you should also think about how you can close this feedback loop so that you can continuously monitor the performance and also continuously improve the multi-agent performance to catch up with the trends in the production system. The second, they also mentioned about the profiling of the multi-agent system. It's also very interesting. Like in their toolkit, the Nemo, right? In their toolkit, they have a profiling tool and able to track what is the latency per LLM call and per tool call. So this is a pre-optimization, right? So I think the blue is the LLM call and green is the tool call. And then you will see like what's the latency span there. This is just one example. So they find one bottleneck of sequential dependency between two cores. And if you can just move from the sequential to the parallel two cores, it's going to save the overall end-to-end latency time. Right? So basically, they have a profile to provide you this picture to show what is the end-to-end latency and what is the per LLM per tool core time use. And then based on this profiling picture, you can also try to optimize it. For example, parallel some tool cores, like those don't have dependency on each other, and then you are able to reduce the end-to-end latency over time. I think it's going to be a very helpful profiling tool if you want to see whether you can improve the end-to-end latency there. They also mentioned about how to select the best agentic architecture for the problem. So there are many different choices of how you can select the most effective agentic architecture. One could be just a fixed workflow. It is consistent and also stable, right? So do LM call, do tool call, do another LM call like this. So, and it won't change. So this is like a static workflow. You can also add a router in the beginning. So based on different use cases and the requirement, you can route the traffic to different workflow. So this is a router-based agentic workflow. It can also be a fully automatic agentic system. So basically, this agent is going to figure out what is the next step to do, right? So it's going to decide it's going to be LLM call or it's going to be tool call. And it's fully depending on this LLM orchestration agent in the end. So this is full flexibility, adaptive, and dynamic agentic system, like or agentic workflows, depending on this orchestration planner agent. Or it can be a hybrid, right? So in the beginning, you may want to do some pre-processing, or you may always want to perform some tool call or code execution to transform the data or to summarize the data in certain formats as the input to the LLM agents. And then the LLM agent here can have some flexibility to do the tool call or call another LLM agent. And then in the end, the final step, it's also fixed. So basically, you can move some part out as a static workflow. So this main line is kind of a static workflow, but like over here is like a flexible, adaptive, dynamic workflow, right? I think the hybrid, they mentioned about hybrid is because you want to save some time and also help to improve the latency. If you find some tools are always going to be called, you just better call it instead of let the LLM agent to figure out like when to call it. In the beginning, I just directly provide the information to the agent, which could help save the tokens, right, for your agent, and also can reduce the end-to-end latencies for that. I think this is also a good call out wherever you want to see what will be a good design for your use case. They also mentioned about reliable LLM judges. We have seen human judges results, right? Like whether it is correct, whether it is relevant or helpful. But if you want to speed up the iterative development and testing of the LLM agent, you may also want to consider a LLM as a judge. So this is to pass the system outputs to LLM and just prompt the LLM to provide a score, such as for the clarity, correctness, relevance, or how grounded it is for the use case. But it's also important that you should not trust the LLM judge until you have human label examples for calibration and show that the LLM judge is consistent with the human judge. And you need to do this calibration from time to time, or else the LLM judge may not be consistent with the human expectation, and then it may give the wrong directions of how your system is performing. So once it's calibrated, then we can use the LLM judge to compare, different agentic design, different prompt variations, model versions, etc. Right? And then this can help accelerate the iteration or iterative development of this process for the quality improvement. So I think that covers the majority of their technical block. They also share learnings about how to build AI agents that will succeed in the real world. And then there are lots of lessons learned when they are building this system to make it helpful for the human analysts. So the first lesson is co-design with the users from day one. You may see the report, right? So MIT report to say, I think like 90 or 95 of the agentic use cases fail in the end. I think that is because it's not co-designed with the actual user. You are not defining the right problem, and you are not co-designing it with the right users. Like what is your target users, right? And just co-design with them from day one to make sure that the development is targeted for real pain points. And also the human expert, the domain knowledge will help inspire and facilitate what is the most effective and best design to automate that process. This should be designed together, right, with the human experts to help facilitate the adoption. Because if it's not adopted in the end, it's not a useful agent. Not just develop it for the purpose of development, but have the end goal, have the users in your mind from day one. So that will be critical to the success of the any agentic applications. The second is when you do the design, Start with simple design and focus on high impact tasks rather than full automation that cover every edge cases or every steps, right? Usually it's like any operation workflow, there are lots of steps to check. And usually one way is to see, oh, which component in your step takes most of the time, right? And then that could give you the most impact to save human time throughout the operation workflows, right? And also it can help earn the early wins by building the trust with the system and focus on what matters most to automate. And then once it's rolled out, get feedbacks and then iteratively improve the agentic system over time to be able to automate more tasks for your operation workflows. The third is people usually forget about is the evaluation. Sometimes like they just roll out one that works, that seems working for one or two cases. That will pose a high risk, right? In terms of, well, since we are talking about the vulnerabilities, I think the multi-agent system or this application also has the vulnerabilities there. So you need to define what is the success metrics in order to say this is a success, or in order to say this multi-agent system works, right? You need to define a label data set, kind of have the LLM as a judge, which is also, of course, collaborated with the human judges to enable a faster iterations of the development process. So I think this lesson learned is critical to actually develop a useful and helpful multi-agent applications in the end. So whichever case you are working on, think about these three in the beginning, right? Before you just jumping into the multi-agent framework and just trying to adopt the multi-agent framework without these three elements in your mind in the beginning. That may not get you any place for. Yeah, cool. That's almost the end of today's talk. And I think this year my focus is to kind of sort out various agentic AI use cases. And I have posted in my playlist on YouTube. So it's like Ian AI Talk YouTube. I think right now, including this one, we have been through like 8 use cases. But at least I think this is a good starting point to see the various agentic architectures, right? Like how people design it, what use cases are they using this agentic AI for? And then, yeah, I think we have seen lots of commonalities. We have seen the lessons learned from all these AI use cases. And I hope that these learnings can be also helpful for your own use cases, and then you can get inspiration from this process as well. And then from the next year, I think I will be more focused on the hands-on, since we have talked about from the high level. And I also expect the framework is gradually, I think it's still very active, but I think it's going to be less chaotic next year, since people have been exploring a lot about the frameworks, about the tools this year.